More factoring today, and today what we're going to do is we're going to start off with the opposite of factoring, which is expanding. So I've got two binomials here. I'm just going to expand. So I'm going to multiply everything in one bracket by everything in the other bracket. So x times x gives me x squared. X times 3 gives me 3x. 4 times x gives me 4x. And 4 times 3 gives me 12. And then I'm going to put these together. So x squared plus 7x plus 12. Okay, so let's just take a look at these numbers a bit and see if we can find any connections. So looking at these original numbers, we have 4 and we have 3. How do the 4 and 3 combine to give us the numbers that appear in this trinomial over here? Well, it seems pretty obvious that those are added together, and there we have them multiplied together. And so if we go over here and we look at something in more general terms, we can see if this always holds. So x times x and x times b, x times a and a times b. We'll end up with x squared plus bx plus ax plus ab. And so this looks a little bit confusing, so let's just take a look at this group in the center. Let's just common factor out that x. I'm going to factor it to the right, because it looks a little bit better when you do that. And you can see that this middle is always going to give us the term, or will always give us the end terms here added together, and the term on the end will always be those multiplied together. So this is our add, and that's our multiply. So the conclusion on that is the middle term is the sum, and the end term the product. In a certain sense, our conclusion is this, that we could go backwards if we want. Okay? That x squared plus b plus a times x plus ab can be factored into x plus a times x plus b. So the trick is finding the two numbers that add together to give you this and multiply together to give you that. Once you have that, those two numbers are just going to go here and here in the bracket when you factor. So let's take a look at some examples. So we want to figure out what two binomials multiplied together to give you this expression. And so we know we have x and x, and we just need to know these numbers here. So we're looking for two numbers that add together to give us 7 and multiply together to give us 10. So what are all the ways we can make 10? We can make 10 from 10 and 1 and 5 and 2. Okay, so we just got to decide which ones are going to give us an addition or a sum that gives us 7. Well, clearly it's got to be 5 and 2. So we just put these in here. Okay, and we can run a quick check if we want to double check that that worked. So x plus 5 times x plus 2. And again, we're just multiplying everything in this bracket by everything in that bracket. We should be used to doing this by now. So x squared plus 2x plus 5x plus 10 is what we get when we do that. So you end up with x squared plus 7x plus 10. So yeah, it checked out. It gave us back the original expression. So the answer to this, the factors that created this, are these guys here. Let's take a look at another one. So we're looking for the factors that when you multiply them together, give you this set. So it's going to multiply together to give us 7, add together to give us minus 8. Okay, so what I like to do is I just write out what numbers multiply together to give you 7. 7 and 1. Okay, so I'm just going to put the 7 and the 1 here. And now I have to pick the signs so that they add together to give me minus 8. Well, both of them would have to be negative. So now just double check that you didn't make a mistake on the signs. And notice that negative 7 times negative 1 gives us positive 7. And negative 7 minus 1 gives us minus 8. So we're good there as well. So that one looks good. Okay, let's keep going. Let's do a couple more. Okay, so we know we've got x here and x there. We're looking for two numbers that multiply together to give us minus 15 and add together to give us 2. So like I said, I like writing out just the things that make 15. Don't worry about that negative quite yet. So we got 1 and 15. We got 3 and 5. So which ones could be different or added together to give us 2? The only set that works is 3 and 5. Okay, so 3 and 5. Now let's think about the signs now. We have to make it so that when we add these together, we get plus 2. Okay, so the bigger number's got to be positive if we end up with a positive number. And we got to take it down by 3 to get down to 2. Okay, so let's just double check. Positive 5 times negative 3 gives us negative 15. And positive 5 plus negative 3 gives us positive 2. So that's good. And again, there's nothing stopping you from running a quick check. And I'll do this really fast. X minus 3 times x plus 5, which equals x squared plus 5x minus 3x minus 15, which equals x squared plus 2x minus 15. So we're good. Okay, another one. So x and x again. We're looking for two numbers that multiply together to give us 10. Right? Multiply here, add there. So multiplying to give us 10 are 10 and 1 and 5 and 2. And we want ones that could be different by 2. Well, this one doesn't work. And that one doesn't work either. Okay, so what that tells us is that we say this is not factorable over the integers. It's possible that you could find a decimal set or fractional set that would work. So 20 times a half or something like that. Okay, to get that 10. You'd have to look through infinite possibilities to see if any of them worked. So all we're really concerned about is if you can get integer values. You know, -1, -5, +4, +10. Okay, so integer values, not decimal numbers. Okay, not any real number, but just integers. Okay, so there are no factors for this. You can't factor this. Okay, let's do another one. So we're looking for two numbers that multiply together to give you 42 and add together to give you 20. Okay, so 42. How could we make 42? Well, we've got 21 and 2. We've got 7 and 6. We've got 3 and 14. And I think that's it. So again, you're looking for two numbers that when you multiply them together will give you 42 and add to give minus 20. Well, none of these could be combined to make 20. So again, this one is not factorable over the integers. And that can pop up frequently even. Okay, and that's a few examples of how to factor trinomials in the form x squared plus bx plus c.